Enamine REAL compounds. First of all, before we start talking about the compounds, we just need to understand what the REAL is. And REAL is an acronym of readily accessible, and that's basically Enamine's approach to design make-on-demand compounds that can be synthesized and eventually delivered to the lab with high success rate and fast. And the idea is basically use well-validated synthetic procedures, in-house validated synthetic procedures applied to in-house qualified building blocks. So these two things need to be met, basically: in-house validated synthetic procedures and qualified building blocks. And while these two are together, we can get the compounds really fast. And this concept has been as a basis of building Enamine's extensive in-stock collection of screening compounds. As you can see, we have here 4 million compounds synthesized since 1991. But to be honest, it's not 4 million; it's like 4.3 million now. And the way it's done, it's basically selected based on our internal criteria on the compound enhancement program, and because that's a kind of compound synthesized using real criteria and basically real approach, the success rate of this synthesis is over 80%. And as you can see, even we've been working even these hard times for Ukraine. During the 2022, we were able to synthesize compounds. Here you can see in a decent amount. So again, when we're talking about real compounds or Enamine make-on-demand compounds, we follow two things, right? So first, that's a validated synthetic procedure, and this is just one of the examples of the validated synthetic procedure. That's a kind of multi-step procedure, and as you can see, basically that's a new procedure, by the way. We've included in the latest release of the REAL space, and with this scheme, we can get a pretty decent amount of make-on-demand compounds. That's approximate number of the space, because we're using 20,000 amines, just 27 this we can call them bridge molecules, and and 20 almost 19,000 amines from this side. And as you can see so we've done already over 2,000 syntheses using this procedure, and average success rate is over 80%, and average yield is 28%. So which is more than enough to get the feeling whether the compounds synthesized in that using this scheme are actually they bind to your target or not. And what we also check experimentally is which building blocks can be actually included in that or another procedure. So that basically comes to another part of the Enamine make-on-demand, so validated in-stock building blocks. So we have this 2-sulfonyl chloride. So that's basically this bridged kind of molecules. And as you can see, so we've set the reactions with both of them, and for one of them the success rate was over 36%, and for another one was 79%. So because of this low success rate, we rather exclude this sulfonyl chloride from the enumeration, and so you won't be able to get a real analogs or real products for this sulfonyl chloride, but only for this. So basically, when we check experimentally we keep an account, we take in account yield and success rate, the tolerance of the functional groups, purifications issues, if any, and obviously product stability. Those are few things that you need to keep in mind in order to the procedure and the building blocks to be included into the real approach. And obviously our real universe is deeply depends not only on the synthetic procedures, but on the extensive collection of in-stock building blocks that Enamine has got during this year, so 30 years of its history. And that's just some drop down on the collection and some basically major classes of organic compounds are shown here, and the corresponding numbers. And as you know, that's the largest single collection of building blocks available in the world. And obviously, this collection is evolving every year. We add more and more compounds to our warehouse, and which actually shows its the variety of novel molecules added, and so we expect the novel real compounds that are derived from these novel building blocks are also appear will also appear in the real space. And again, that's the kind of our production rate. Yeah, we obviously in 2024, but that was done for up to 2023. And as you can see, again, even in 2022, we're able to deliver almost 20,000 new building blocks. Again, here we're talking about new building blocks to Enamine's warehouse. So few words about the place of the real compounds in the Enamine universe, or Enamine collection of the screening compounds. As you can see, and as I mentioned, the majority of screening compounds synthesized by Enamine, they're actually derivatives of the real compounds. So the whole universe of real compounds, probably we're talking about zillions of molecules, which is really good, large number. And that includes the in-stock compounds, Enamine liquid stock collection, Enamine pre-plated libraries, and obviously that's a subset of of the real database. So imagine you want to try to work with us. The best and cost efficient way to start working with Enamine, that's obviously pre-plated libraries, which we have a lot, over 70 different libraries available for quick delivery in different formats, including assay ready plates. Then you can take a look into our liquid stock collection, which is a set of over 1 million samples stored as solutions, frozen solutions in DMSO, and that available for really quick and efficient cherry picking and preparation of your collection of interest. And if this is something that not enough for you, obviously you can go into the screening collection, which is 4.2 million molecules, and those are neat samples available for cherry picking and quick formatting and basically delivery to your lab for testing. And obviously, once you kind of identify your hit from in-stock collection, which is again the most the fastest and most cost efficient way to start working with Enamine as compounds, you can look for the analogs, or we can help you to do this in our so-called real database. That's about 6.8 billion molecules, and it contains molecules with I would say, strict lead-like profiles or focused towards that kind of molecules. If there is something, and this database can be searched online on Enamine store or ChemSpace or other resources. And if you want more molecules, more analogs, you can go into real space, and that's basically a fragment-based space that is available through BioSolveIT's infiniSee, and basically, and some other tools, and there you can find analogs. And obviously, you know that infiniSee allows you to search analogs not only by similarity substructure, but by also so-called feature similarity, which is really great way to find similar molecules based on the activity profile, but you know, they may have different structure, which opens the way to scaffold hopping. And you know, both those space, you know, this real database and real spaces, they're focused towards, again, lead-like molecules or strict lead-like molecules. And this is something that probably people start their projects with, but in some case they really need larger molecules. And we've decided basically to expand those two spaces and add larger molecules, basically shifting molecular, you know, average molecular weight into the higher Daltons. And with that, we're able to create the so-called xREAL space. Now it's 2.7 trillion molecules. It's worth mentioning that all this kind of real compounds from the real universe, they're synthesized typically in 3-4 weeks. If we're talking about selections up to 300 compounds, the average success rate is over 80%. And the compounds can be delivered in different formats as neat samples, solutions, etc. Yeah, and yeah, that's basically, again, what I said. You know, some availability options for different products from the real family, and obviously, you know, the xREAL space, which we've been talking today, is something new. And I'll just again do quick analysis and what we have for each of these products, the real products. But before I go there, I'll just want to mention that you know, this real concept is actually something that you know, has got attention by many research groups. And as you can see, number of publications citing Enamine REAL it's growing, and now it's over 150 papers already. And again, publications are different. Some of them, they explore methodology, some of them they show the discovery of novel compounds, some of them they show applicability of that or another model to search in a huge, ultra large chemical space. So yeah, that's a few things about this kind of compounds that we added. So basically, you know, that's real xREAL space. We've added some new procedures and some reagents, along with, you know, that allowed us basically to expand the space, as I said, to 2.7 trillion molecules. That's a basic information about, again, the space. As you can see here, you know, the real space is selected. You know, again, that's a subspace of the real compounds universe. It's selected, you know, to have really like lead-like compounds. The real database, it has even more strict criteria for the selection of the compounds, and you can see that average molecular weight is shifted toward lower Daltons. And as you can see, that's just a comparison for real space and xREAL space. The average molecular weight for the xREAL space is shifted towards, again, higher Dalton. It's around for 520 Daltons. So it's again, we have more larger molecules there. And these are just accessibility options for this xREAL space. So it's available through REAL API. It's available through ChemSpace as a part of their discovery services, and that includes some fragment growing options, as well as vSynthase approach, and the search option will be available in the future. And obviously, this space is available through infiniSee xREAL, which we'll be talking in more details. Alex will show you basically how to use it a little later. So that's ChemSpace. If you need to help in finding hits, go to chemspace.com, and they help you to identify them using different virtual screening technologies. That's basically infiniSee xREAL. That's where you need to go, and where you can get this xREAL real space navigator here. And as you know, it actually, you can get it for free now. And by the way, there are still 65 days left to get and use the infiniSee xREAL tool for free. And you remember that when you order during this time, you can get a 10% discount from Enamine on the xREAL compounds. And this is just how to order instructions. And again, it's actually written over here. You can expand it. It's on BioSolveIT's web page. So basically, this will show you really quick manual how to order. So basically, you need to send the email to libraries@enamine.net, and I will provide you with the quote, and basically you can proceed with ordering. So that how it works. And with that, I would like to thank you, and I give word to Alex, basically to show you how you can search and how you can really access all those trillions of our real compounds. Thank you very much for your attention.
For my part, I actually thought about how to enlighten or put it into a drug discovery context, especially infiniSee and xREAL. Therefore, I prepared not only the technical aspects, but also a little bit of use cases and applicability studies, just to provide you with some flavor to the whole concept. So what's on the agenda from my side? I will explain what infiniSee xREAL as a software is to you, cover some technical aspects together with the property distributions of the xREAL space. I will talk a little bit about for modern application case studies. Since you also mentioned quite a lot about the launch promotion, I will keep it very briefly. And by the end of the day, I will provide you with some additional tips and tricks how to operate efficiently within infiniSee xREAL. So first things first, what is infiniSee xREAL? infiniSee xREAL is a chemical space navigation platform that exclusively screens Enamine's xREAL space. So it's only dedicated to dive into the xREAL space. All the features that you are familiar with, all the different search modes from infiniSee are also included in infiniSee xREAL. So if you have the scaffold hopper, analog hunter, or motive matcher, all the favorite modes you like, they can be also used within infiniSee xREAL, together with the analyzer mode. A little bit more of the comparison between xREAL and the real space. Ultimately, xREAL is 50 times larger than the real space. The question always arises, well, it's a numbers game by the end of the day, so do we really need larger spaces? And the final answer is yes, we need them, especially as you mentioned, we have like now a shift, I would say, from drug-like properties to more beyond rule of five properties. So those hard limits of the rules of five become more and more, I would say, not outdated, by we shift a little bit towards, higher numbers. So therefore, providing access to more compounds is always a good pick. And there are so many overviews and reviews that actually explain quite in detail that if you have larger hunting grounds, you actually find more and more relevant compounds. As Yuri also correctly mentioned, the reactions have increased within the xREAL space, now at 180, consisting of, what was it, 3,000 something sub-reactions, so a huge number of reactions, a lot of encoding involved. And usually also people ask from the pharma company side, how many steps are involved on those products. It's still 1 to 2, right? So 1 or 2 steps required to actually get your hands on the xREAL compounds. A little change from infiniSee to infiniSee xREAL. As of now, infiniSee xREAL can only be accessed by infiniSee itself. So with the graphical user interface, there is no support of the command line tools right now. What does not change though is that you still get your compounds within a few weeks at a very competitive pricing and 80 to 90% success rate depending on the compound class. But still, you get the full version of infiniSee with the full modes and the analyzer mode. So a little bit more of detail. We, as BioSolveIT, developed novel methods how to actually screen within ultra vast, large compound collections. And we developed several modes for this one. The most prominent one is the scaffold hopper, where we capture the fuzzy pharmacophore features of a molecule and kind of like assemble the arrangements of functional groups back together to find the best match here. Great for scaffold hopping, obviously, scaffold hops, scaffold replacements, but you will also see in my case examples that it's also quite valuable for very directed search. Furthermore, we also have the analog hunter, so especially the comp camps are, I would say, everybody use molecular tiny motor-like fingerprints. So this is the mode of your pick. We use ECCFP4 within infiniSee xREAL, where you can mine for very close analogs of your query compound with very high fingerprint similarity. Last but not least, my personal favorite is the motif matcher, where you can perform substructure matching. This does not only contain exact substructure search, but also the longest continuous arrangement of heavy atoms within a ligand compared to the query compound. So why I'm mentioning this, you will see it also in the upcoming slides. Similarity does not equal similarity, and each drug discovery scenario requires, sometimes different tools to get the right compounds. So about infiniSee xREAL. So what's so special about this one? The first thing is it runs locally. You just have your laptop or your hardware in front of you, your tower PC, and every calculation happens in front of you. So you don't need any, larger quantities of server farms or anything. You don't even need an internet connection. So everything that happens in front of your eyes. Next thing is you are not relying on third parties. Everything that you calculate remains in your own periphery. As I mentioned, you don't need any internet connection. So it's not even like we can see things that happen. Everything is quite secure. And also you're not relying on external services. So you can do everything in-house. You don't have to communicate with other people, which ensures data and privacy and security on every single aspect, and also streamlines the work progress quite much. It's cost effective. As I mentioned, you don't need a server farm. I mean, like everybody who was involved in some form of cloud services, you know how expensive things can become, especially if you work with large numbers. Here we have 2.4 trillion molecules that can you search within minutes on your own hardware, very fast. And it's only your hardware, right? You just have to get your hands on a PC, install infiniSee xREAL, and run everything, which also is, I would say, quite cost effective for the output you get. Next thing is you get full control over things. Given the idea that we actually provide you with a lot of different search modes where you can also apply different settings, you can parameterize a lot of things to get the compounds that you actually want. So if you have worked with any form of web servers, you know, things can become very limiting or not accessible in the case of some websites I've checked. This is where you can fine tune your things to actually get your hands on quite valuable compounds that are also accessible. And last but not least, it's the exclusivity. So it's right now one of the largest hunting grounds out there. And if you want to play in the same league as the others, it's actually your only option so far to do things in-house by accessing the xREAL from infiniSee xREAL as your entry point to the ultra-large chemical space. A little bit about the technical aspects of infiniSee xREAL. Important disclaimer, for infiniSee to perform efficiently, you need 32 GB of RAM. It's, I wouldn't say common yet, but it is accessible, and the hardware I've checked is not that expensive. usually, if you are CompCam, you actually have 32 gigabytes of RAM somewhere around. But I think it's a quite decent price to pay if you would like to dive into those huge numbers. Some aspects to that, everything that happens on your hardware. It's not like there is no API involved. If you put something into the query of infiniSee xREAL, everything happens within the realm of your hardware and your resources. You don't even need an internet connection. So everything happens only in your software. Your privacy is 100% saved and covered. This also features the ordering process. Your query molecule is by default not included in any form of export. So if you don't want to share what your start of the idea or start of the project was, we will never know it and nobody else will do except you want them to do. All three most prominent operating systems are supported, so Windows, Mac, and Linux. And you can retrieve up to 100,000 compounds with one single run. The best part is obviously we have now the launch event running, so it's completely up to you. You can download the software and test it risk-free without any strings attached, no commitment. If you don't like it, it's up to you. You don't have to purchase anything, and the license is valid till November 30th. So you have the full time frame to actually accessibly test the software to your heart's content, and especially important, you get also access to all search modes within infiniSee xREAL. So now a little bit about the properties themselves. As Yuri mentioned, we have a little bit of a shift here. So from the drug-like structures to the more lead-like side. On the left side, you can actually see, oh, where's my pointer? Here's my pointer. So we are now here at trillions. The largest part is actually here. So over 1.1 trillion molecules are in this 500 to 600 Dalton zone, but you also have a quite decent amount of close to 700 billion, which is still a huge number within the lead-like and drug-like zone. As for the log P, quite nice distribution, so we don't have many too highly soluble compounds, to be fair. And based on the calculations, we have a lot of compounds with very high log P values, but this is given the perspective that the compounds also increase with the size. So therefore also the log P value increases subsequently. But nevertheless, all of those safe zones, as I would call them, are pretty nicely covered with at least 500 billion compounds per each histogram bar. As for the other Lipinski's parameters, the H-bond acceptors, fairly nice distribution, so less than 10, I would say more than 70 to 80% are covered by those compounds here. As for the donors, very, very nice, only few exceptions in the 6 or more, and all the rest is covered by Lipinski's rule of 5. Rotatable bonds, quite some diversity here. We also have some alkyl chains in the more than 10 section, but in total, a very, I would say normal distribution, Gaussian distribution for those compounds. And for the topological polar surface area, the topological total polar surface area, we see again a very beautiful distribution in this area. Heavy atoms, honestly, I have no idea why I included this because this number is just kind of like, doesn't make too much sense for me to kind of like evaluate, but you can see quite nicely that the distribution of those compounds actually is pretty Gaussian and normal. So not so much about the technical aspects. Now let's dive into the use cases. And for this, I have prepared like 3 sections from small molecules and then going into larger sections. So as for the smallest compounds, basically fragments, I thought it would be a nice idea to compare the real space and the xREAL space in regards to the commercial availability of hinge binders. So those are the 4 of the more prominent ones, I would say. And you can see here in the real space, you can go up to 450 million for those for this motive, and down to 990 million for this indole here. And if you go to the real space, things change quite drastically, I would say. We easily breach the billions for those prominent motives with close to 6 billion for indoles here, So it gives you quite a good idea how much of potential value is inside those spaces, right? The next feature I would like to highlight is basically because I just stumbled upon this review from Lutens and Carson, where they just kind of like reviewed the screening of visual screening campaigns of ultra large chemical spaces. And I thought those are actually the perfect use cases or the perfect examples to highlight what you can expect within xREAL if you start with something that would kind of like emerge as a screening hit or as a visual screening candidate. Another thing that I would like to highlight is this little comment here from the authors. Make-on-demand chemical libraries will likely reach more than 1 trillion compounds in the next few years. They were not completely wrong, but this review is from the summer of 2024, so it's like 2 months old max. And yeah, we are already there. So it is already almost outdated, but it just kind of like put a smile on my face. So this is a compound I've picked from the review. On the left side, compound 747 with an Ki value of 0.9 nanomolar. And obviously, if you have a screening hit, right, what's the first thing you do? You ask yourself, what is kind of like the proximal chemical space around this compound? So what I did, I put this molecule into infiniSee xREAL and run each mode on that and ask myself, what is there? What is the compound I can retrieve that is similar to this one? And the good news is here, I actually am able to retrieve exactly this compound as the first rank for each mode, which is, I wouldn't say surprising, but it's always nice to see. And for the scaffold hopper, just to kind of like go through this example so you get a feeling for those different search modes. What happens? So basically, we can now actually expand the cyclopropane into into the spiral system with a cyclopentane here. Or we can also get something like a little bit more merged. So we kind of like now we have this ether group and we kind of like push it into a ring system. To cover also the results here, those are the among the top 10 or 20 ranks. So this is what you will actually see as the first emerging hits. It's not like I went through, I don't know, 10,000s of compounds and then completely went down the list. So this is actually on the top ranks, what you see on those slides for each and single result you will see in the upcoming slides as well. For the analog hunter, again, it's a molecular fingerprint. What you can expect from the analog hunter, especially in regards to amides, this is where a little party happens every now and then. So you can actually see here that you actually extend this amide with another amide to kind of like match the thing. It's just part of the game for the analog hunter, I have to admit. So it is quite playful in those areas. As for the motive matcher, we actually, since we have the same structure, what we can expect that we also receive structures that are a little bit more decorated, so just more additional heavy atoms on our query compound. And this is actually the case, and this is true. So we actually get an ester in this position and an additional ester, but missing the meta group here. For this beautiful compound, I won't read out the full number, but it's like an COVID treatment drug candidate for the main protease. Again, we are able to retrieve the identical molecule as the first rank, but now things become a little bit more exciting, I would say. From this spiral compound, we get a bridge system as an alternative, so I would say closer to a scaffold top, or we also get kind of like a ring extension from a 5-membered ring system to a 6-membered ring system. For the analog hunter, we can actually downsize a little bit, so from the cyclobutyl group now to a cyclopropane, and also an extension, this time also with an oxygen. For the motive matcher, unsurprisingly, we get a little bit more of decorations. So here now a methoxy group because we got an additional heavy atom on this side chain. And also in this area, we are now getting an additional oxygen. This may feel to some people a little bit more of, I would say, counterintuitive to some degree because it's like a double bond and we get rid of this double bond here. But if you think about the tautomer here, if this would be a hydroxy group with still the double bond inside the ring system, this is just another representation. But ultimately, we all know it's kind of like not the most prominent or not the most stable form. So therefore, also infiniSee corrects those tautomers subsequently in the results. What does happen if we don't get this exact same compound? So on the left side, we get this beautiful fella here from MEC1 as a MEC1 inhibitor. For the scaffold hopper, we actually get to miss out on this hydroxy group, which is a pain, but it's not so bad. Then we get an alternative for an ester. And what I really like that you actually kind of like merge now those two parts here, namely the nitrogen of the amides together with this 5-membered ring system into one single thing. And if you now flip this one inside your head, you will actually see that the geometry kind of works out in one way or another, but it doesn't work out for the drawing. So it would be a clash to just flip it inside your head. In the log hunter, again, we actually get the same compound as the first ranking one. Then we actually get the second one at once. So you can actually see the ranks can also change for between different search modes, given the algorithm, obviously, because similarity does not equal similarity and can be kind of like weighted in one group can be weighted more in one algorithm and less in another, which results in changes in ranks. As for this part, we can actually see, as I've mentioned, the little playful part around the amides. And you can see here now a little bit more of an extension. So you are not always lucky, but it's also up to you to check the results for their relevance to you subsequently. Sorry. Then for the motive matcher, again, we get the ester functionality here. Then we also get some decorations around other parts of the compound here with the chlorine in the center phenyl group, and also kind of like stripped compounds where we miss out on the hydroxy group but get the ester functionality in this area. So this was a little bit about the, I would say, exploration of the proximal chemical space around a compound that you may have discovered. In the next slide, I would like to dive a little bit more on the advanced drugs. And to be honest, I'm a huge fan of transparency. Therefore, it's quite important for me to set the expectations right for everybody. What we see on the left side are very complicated drugs. I think we can all agree that this is something you cannot achieve in any way in one step, except you get like those huge building blocks in one. There's a lot of complicated synthesis involved, right? And this is what also you should keep in mind when you play around with compounds, leaving phase 0, kind of like entering the clinical stages. Those compounds are usually heavily optimized. It's not like a single round of iterations, which is very, very rare. Usually you have a lot of iterations with hundreds of analogs that are synthesized. And therefore, what you put in as an FDA-approved drug or phase 2 clinical candidate, those compounds underwent a lot of modifications, and therefore the synthesis is usually involving more than 2 steps, 4, 5, 6, 7, you name them. And therefore, if you have a complicated compound in front of you, do not expect the space to cover this exact same compound with only 1 or 2 steps. It cannot work out ultimately. So therefore, if you have a complicated compound, keep in mind that the space itself is not the perfect source to find the exact same thing to cover the whole compound. Parts of that, absolutely, yes, 100%, but not the whole structure. So I am a lazy person, so therefore what I did, I screened for the first-time disclosures this year from the ACS meeting and the AFMC ISMC this year, and I picked 4 candidates I would like to talk about in the next few minutes to give you an idea about, okay, what happens to drugs that are now really kind of like in this final stage where they really get evaluated and people are actually proud to present them. So advanced drugs and what infiniSee xREAL can do for you if you search within it. So the first one is from Pfizer, acute compound, and I'm just showing the results that I really liked from each mode. What you can see here, we actually get a lot of similar compounds. You have to be careful about the placement of the decorations, especially in the scaffold hopper, because it's agnostic towards that. So be careful about if it really matches your needs. But in total, I would say it's a smaller compound. Smaller compounds are very nicely covered. So anything kind of like lower than 400 Dalton, you have a very, very good chance to find exact same hits or very, very similar compounds that you can work with. And also you should keep in mind that you can order different amounts of compounds, right? So it's not like you're only limited to order 1 milligram of a compound for screenings. If you say, well, I actually need this building block to keep going, you can also request more of the compound to use as a building block for your own research and in-house synthesis. what we can see here, we can kind of like nicely match the idea of the ether group here, and also in some cases kind of like nicely can cover the arrangement of the fluorine substitutions, likely due to metabolic reasons though. As for the motif matcher, we nicely see that we can actually cover a lot of areas that we like. What we also can cover is actually bioisosteres. So the thiophene rings is a benzothiopene, can also be merged into a naphthalene because the continuous chain length, which will be kind of like around this and everything, is still going. So we can allow modifications and expansions of ring system with a motif matcher, which kind of like opens doors, right? So if you just perform a very straightforward XX substructure search, things can become, I wouldn't say ugly, but kind of like not even depressing, but frustrating to some point, because if you do an XX substructure search and your structure is not exactly covered, you don't get anything. But the motif matcher never leaves you standing in the rain, and you can get at least very nicely complementing compounds matching your query. So therefore, my recommendation, if you work with smaller compounds, try the motif matcher, because this is where you get, you know, the most similar flavor to your compounds. I really like this compound because it's a covalent drug candidate. Obviously, we have a beautiful Michael acceptor in this area. And to be honest, this compound is not very complex, right? But the searches here are not able to retrieve it. This is also to be transparent, but we retrieve actually quite interesting results nevertheless. So what do we see? We actually can get a lot of covalent warheads from infiniSee xREAL. And again, for the scaffold hopper, we actually see nice bioisosteric replacements, or at least it gives us the same flavor, right? We still equip the covalent warhead. We kind of like merge those both ring systems into one. We can argue if this is really kind of like having the same vibe because we are still lacking in a hydrogen bond donor with a missing amino group. But nevertheless, we kind of like merge those two ring systems, and arguably we can still cover the same arrangement to some degree of those both nitrogens here. In those sections, kind of like trying to capture this morpholine motif a little bit, we can see additional ring systems that are included, kind of like freeing this amine from the ring systems, or trying to imitate it with kind of like nice structures, which also provides you with more playgrounds to screen for compounds that may display favorable ADME properties, right? What I really, really loved to see is actually the analog hunter results. So ultimately, we can somewhat keep the covalent motif here, kind of like still missing out on this oxygen or an hydrogen bond acceptor in the ring system. But nevertheless, we also get a nice ring system here to kind of like mimic the phenyl group system. And we can also kind of like try to imitate this hinge binder like-ish motif, I would say, because of the hydrogen bonds acceptor and donor with this particular motif. And what's really, really nice to see is that you can also find novel, new modalities for the covalent warhead, like this carbamate here. So it's always kind of like very interesting to see what you can retrieve with different search modes. It always makes sense to kind of like go through each one to get an idea, okay, for this project, this particular search mode provides me with the best results, or at least from my expertise and my knowledge, which matches exactly what I would like to see. Next thing is what we would now define as a project-like structure. And I have to admit, I wasn't aware of this approach or this perspective, but it kind of like just popped up. Enamine's xREAL is actually a gold mine for project design. What do I mean by this? You have a lot of those E3 ligases motifs inside xREAL with kind of like very different substitutions to kind of like just match the geometry you need for this particular project. And the building blocks you retrieve are the compounds you retrieve can be used really nicely as a building block himself. Those are the results for this matching compounds with the scaffold hopper this time. If you would really match the drug-like perspective of those things, this is what you can expect. You can nicely see that you try to mimic this halogen and this ring system in this area. We are also able to retrieve even something with a trifluoromethyl group. And in the subsequent parts, you also kind of like get this nicely decorated pyridines with a chlorine here. Now to dive a little bit more on the protect aspect, protects are usually consisting of three parts, right? You have a target ligand, so basically a part of the protect that is binding to your target structure of interest. Then we have a linker, and then subsequently we also have the E3 ligand that engages with the E3 ubiquitin or any protein degrader, depending on the use case. So the idea is, well, my target ligand is something I have at home, right? This is something that you have synthesized, that you have grams of. The idea is it's already in this stage where you can just kind of like put something on top of it to make it a protect, right? The only question remains is what kind of linker would I like to use? Ultimately, the way you approach things is usually you look up what E3 ligand is available with a attached linker, and then you just purchase what is commercially available. But this is limiting, right? If you really start to think about, okay, I really would like to play around with different linker lengths, also maybe decrease rotatable bonds, so maybe include some more static groups like 5-member twin systems or 6-member twin systems. Also play around a little bit with solubility or kind of like check what is a good idea to make it a compatible formulation in the subsequent steps. You need more of those things, right? And it's only a few that you can actually purchase commercially in this combination, especially if you would only have like particular dedicated exit vectors which you like to use. So this combination of linker and E3 ligand is something that Explore can you provide a ton with, right? There are so many compounds there. So in this example, this is actually what I have retrieved from the from Explore with a motif matcher, and you can actually see that those compounds are stuff that you can easily couple to your target ligand, right? Simply use the motif matcher to look up whatever E3 ligands you need, and just kind of like let it grow, buy it in whatever numbers you need, and then use it for the in-house synthesis. Last but not least, the drug-like aspects of compounds. So arguably a Bayer compound on the left side, it is drug-like-ish, right? So this is kind of like, if this would kind of like enter the market, you would say, yeah, it's a drug-like compound. So what we can retrieve for this kind of stuff up to here, we are getting actually the exact building blocks, so which is quite nice. And for the left part, we get nice modifications that still match the vibe, at least for me, in regards to we have a basic nitrogen in this area. So ultimately, very drug-like compounds with kind of like a little bit more of, playful connectors between them. So the results you get actually are heavily dependent on what structure you use. So therefore, it can always make sense to kind of like play around with your template a little bit, adjust things here and there, because it will heavily affect also the results you're able to retrieve. Last but not least, as I've mentioned before, just because you get so many compounds that you can easily purchase, it's like a gold mine to play around with really ADME properties to see, okay, if I play with new ring systems, how does this affect my ADME properties? Why is this one a very interesting compound? So think about how to actually implement it inside your workflows to just add an additional layer of properties into your filtering process. So people ask, okay, it's 2.4 trillion compounds. How long does it take for me to actually screen compounds? And this is what I have collected here. So those are 13 or 14 of the first-time disclosures of this year. I have run all of them and every single mode. If you are interested into this list to open up an infiniSee xREAL, it's kind of like reach out to me, connect with me, type into the chat, and I will provide you with a project file so you can also play with the results yourself and see what I did there. For the runtimes, the fastest mode is obviously the N-log hunter, usually taking not more than 2 minutes, in some cases a little bit more, some cases a little bit less. 3 minutes for the N-log hunter to get 100 compounds, and it doesn't kind of like scale linearly. So if you go for 100,000 or 10,000, you don't need like 10 times or 100 times more time. It is a little bit more, I don't know, few minutes. So don't be shy, go into the higher numbers at any time. Second fastest is the scaffold hopper, surprisingly, but it's also given to the fact that we had actually implemented a new performance boost to the scaffold hopper, so it's now even faster than it was before. And again, very decent runtimes to retrieve 100 compounds. And last but not least, this is where we enter the, I wouldn't say inconvenience time zone, but this is where you can get a cup of coffee while doing the searches. It's for the motive manager, 2-digit numbered calculations. Don't ask me about this one. It's the largest compound, to be fair, but I think I also run other calculations in this for this compound. So this is pretty uncommon, let's say. So Yuri already summarized things quite nicely, just to kind of like conclude things. The launch promotion is till November 13th. You can test the software without any strings attached, without any commitment. Download it, try it out, and just enjoy it. It's really nice to use. It's fun. And about the discount here, so there is a little bit twist to it. If you order compounds from Enamine REAL within this time frame to November 13th, you get a 10% discount. And it's quite easy to achieve. Once you get your results in place, you have to export them. So simply click on the compounds you would like to order and then export results as and provide us with an SD file. But it's also explained in the FAQ section of infiniSee xREAL. Just to kind of like also calm you, we will never know what compounds you used for the query. It's all masked. So there is also an option you can always check for yourself. Per default, the query is always masked. If you would like to share results in-house, you can also turn this off. Then also the template structure will be included in the SD file export. But for us, nobody will ever see what compounds you used as a query. So for the last minutes, just to kind of like my last take-home messages to improve your life and make mine easier. We have an infiniSee xREAL guide that is available on our website to download, which will guide you through step-by-step how to get things, how to download stuff, how to search things in each mode. Just download it. Everything is basically answered there. Some tips and tricks I can provide you with. Number one is make your query simple. So don't use a very complicated compound, especially if it contains halogens. Kind of like get rid of stuff you don't like or don't need. Like the best part you can actually use as a query is the smallest pharmacophore of the compound you can think of. Especially halogens highly affect the rating of the fingerprints. So therefore, you can introduce halogens at any time, right? Somewhere later. But for the initial steps, kind of like if it's a possibility for you, just remove them from the query compound and then start your search without them. Same goes also for things that you can easily introduce, like an amide coupling subsequently. Remove it, start your search with kind of like the stripped off compound or precursor to see what is the most similar structure you can retrieve from that. Tip number two, analog counter is the fastest mode. So before you fully commit into a search, which may take some minutes or 1 hour, depending on what parameters you apply, just use the analog counter to check, okay, what's inside the space that is there anything even for my compound? Run an analog counter search, and within 2 minutes, you get an idea of if there's anything in the proximity of your query compound. Last but not least, juggle with your results. If you find something that you really like, just reuse it as a query compound, and then do an additional one to check for anything related to the result molecule. And this is where you obviously get a lot of results. So play around with that as well. And some handy search settings. Since time is running out, I will just keep it very briefly. Within the scaffold hopper mode, you can increase the diversity of the compounds you retrieve. I have like a backup slide if people are interested into that. So if you would like to work with more diverse set of results, you can actually adjust the diversity here. As for the scaffold hopper and motive matcher, you can apply local constraints to fine-tune your results. And for the motive matcher, feature introduced in the latest update, you can actually also define how many additional heavy atoms you would like to have. Very interesting if you would like to work with a fragment binder, which is in the, I don't know, 200 data section, 250, and you would like to see, okay, what compounds are in the range of a drug-like or lead-like structure. You can just tell it, okay, give me like 6 additional heavy atoms, which is a Fernier ring system, up to 10 or whatsoever, and then work with this size range subsequently. We are reaching the final stages, so therefore, if you are not part of the Chemical Space Club yet, please feel free to join on LinkedIn. This is where we share the latest upcoming releases, anything that is happening on the ultra-large chemical spaces. So LinkedIn, or use our redirectory at biosolveIT.com/chemical space club. It's a free community. It's always nice to be there. And with this, I am ending the official part, and Julie and I are more than happy to answer your questions if there are any.